record that there. Okay, so it looks like we're recording really well, and we're going to share the screen here so you can see what I'm doing. Let's use the whiteboard. I've never used the whiteboard on here. This will be nice to discuss what these are all about. So, all right, so in MATLAB, what we've normally done is we've done one of two things. We usually have some kind of a script, so some kind of M file, right? And sometimes we'll write some code in there and then we'll run the script. And as we run the script, run, should probably just type in there. But anyway, as we run the script, then MATLAB gives us some kind of output. And that's fine. And inside the script, we just have these lines of code that do different things and whatever. And that's been our method of operation for a lot of what we've done. In class, we've done quite a bit where instead of having an M file, we type things directly into the command window. So you have your command window here, and we're typing things directly in here, and we hit enter, and we get some kind of output after we hit enter. And we can do, you know, line by line code that way and test things out that way, but we still get some output. Nice. That's very ugly looking, but maybe I should do it differently. Maybe I should do it this way. We're just playing around at this point. So let's do a draw a box. There we go. Draw another box. That's much cleaner. And then we have running things. And over here we get some kind of output. Put it right here. Oops. Delete that. Go to text. And you get some kind of output. Right? Over here. Put that right on top of that arrow. Get this screwed away. Okay, so anyway, there we go. So we're getting output every time. Each one of these goes to some kind of an output, and that's the kind of the idea here. Now, this one being our M file. This one being our command window. But now we're going to do something a little bit different. And this can be quite useful for us using this little tool of drawing here. We're going to do something a little bit different. We're going to create an M file, but we're going to call it a function. And just like functions in mathematics, it's going to essentially have a purpose. It's going to do something. So it's going to be a function now. And just like the functions in mathematics, there's always something that you put into the function, and then you get something out of the function. So the idea, kind of the paradigm behind this is going to be a little bit different. We're going to have not only code, but we're going to have an input. We're going to have an input, then we're going to have a function. I'm kind of liking this whiteboard, it's nice. And then the function will give us some output. And the advantage to this is that these functions, as we call them and as we make them, we're going to be able to save them as M files. They're going to be M files just like we made up here, where we just had a bunch of code in the M file. But the name of the M file is going to be the name of the function, and we'll be able to use them just like we use the functions inside of MATLAB. So for example, in MATLAB, we have the sine function that is one of these little files that MATLAB kind of keeps in reserve all the time. And we input an angle and it calculates the sine and it gives us an output. And MATLAB is full of these kinds of functions, but we can actually make them ourselves. We can make custom functions, and then we can save them in our MATLAB space, and we can use them as we want. And that's what we are going to be doing today, is we're going to be creating functions that accept an input, or you can even accept several inputs, many inputs, and then it will have some kind of an output that you can use. And then this function here just kind of stays the same. It just keeps cranking out the same thing. The function is essentially a machine. It's like a toaster. You put bread in it and you get out toast or whatever. It's just a machine that does some particular thing. If you put in an input that it recognizes and understands how to do something with, it'll do something to it. And it does the same thing every time to everything. And that is the idea behind what we're going to be doing here now. Let's stop sharing that and let's share now my desktop. And let's go into MATLAB and take a look at this. Where's my MATLAB? I lost my MATLAB. The important thing to realize about making functions is that the syntax is quite important. We have to be very careful about how we create the function so that it does work properly every time. And so we're going to start with, let's see, what should we start with? I'm going to try to wing it through this because I had all this prepared stuff ready to go that I could follow to make sure I did it right. But we'll just kind of make it work here. I think I can use this, one of our textbooks, to give me some guidance on how to make sure I do this right. So I'm actually using the Crash Course on MATLAB book that's in our, it's available in our online thing here. And it's in, we're going to go to chapter 3, Scripts and Functions, page 25 it is. And we're going to follow along through that and see how it works. So, scripts are what we have been using so far. And now we're going to make functions. Let's take a look here. What are they doing? Well, they don't really give us a... Well, okay. All right, let's start off. Let's go ahead and do this. What we want to do is we want to open up an M file. So you can go ahead and do a new, click new here. You can click script if you want. It'll be an M file, but you can also click function. Now this is a new feature where they actually set it up for us, kind of how it needs to be formatted. So they're building part of the M file for us essentially here. And notice that this doesn't have a title yet, and we want it to have a title. And the title is going to go over here. You can see that this is also called untitled, and this is the same. So what I'm going to do is go over here and title this something. Let's title it quadratic. We'll do the quadratic formula first. We'll call it quad form, the quadratic formula. And I can go ahead and I can save this right now, and it'll want to save it as quad form because I put that in the title, the place where the title is. And essentially what this first line does is this first line tells us that we're making a function. So you use the word function and it tells MATLAB that everything after this, before the end, is a function. And you always have to have an end at the end of your function, otherwise it will not necessarily work so well. And then you put these square brackets, and inside the square brackets are going to be the things that are going to be put out, or the output of your function. And then after the title of your function, after the output arguments, you have this equal sign, and then you have the title of your function. And then you have parentheses, and you're going to have input arguments. You can have multiple outputs and multiple inputs. So for the quadratic formula, we're usually going to have two outputs, and we'll call them x1, comma, x2. Two outputs. And the inputs for the quadratic formula usually require that we have 3 inputs. So we're going to have 3, we're going to call them A, comma, B, comma, C. Right? Now, if you don't remember what the quadratic formula is, it essentially has to do with equations that are quadratic, of course. So let's just review that really quick just so I don't confuse the heck out of anybody that's not sure about the quadratic formula. And let's do some text here. Sure, why not? Text. So an equation that looks like this, where you have A times x squared. Let's see, can I do a... It's not going to let me do a squared, I don't think. I'm going to draw this instead of... So we have A times x squared plus B times x plus C equals 0. Where A, B, and C are any real numbers you want, and they can even be imaginary. So really, they can be any numbers you want them to be. This equation turns out to have a solution that we can always figure out. There's always a solution to this equation. And it turns out that one of those solutions is the solution where x equals negative b plus the square root of 4, sorry, not of 4, of b, there we go, squared minus 4ac, 4 times a times c, all over 2a. And there's another solution, we call this one x1, we call this other solution x2, is actually the same thing, negative b, but it's minus the square root of b squared minus 4ac all over 2a. So these two solutions are going to be the solutions to this equation, this what we call this quadratic equation, and we're going to build a function that if we can figure out what A, B, and C are, and if we can write those into the function, put those into the function, it will calculate what x1 and x2 are by plugging them into these formulas. And that's the idea behind this particular function that we're going to use, we're going to make here. So now we need to close this. Go back to sharing my screen on my computer. Okay, now, so we have the two outputs, x1 and x2, and we have the three inputs, A, B, and C. What are we going to do with the inputs? So we have some lines here of explanation already. So this is, I'm going to say, this function solves a quadratic equation of the form a x squared plus bx plus c equals 0 using the quadratic formula. And it may be a good idea to mention, or to talk about the variables here. So say A is the coefficient of the squared term, B is the coefficient of the linear term, and C is the constant coefficient. So I've made a nice explanation of what this is. You could even put your name in it, designed by Jared Daly or whatever else, but in the end, what we want to do is write the function. So how do we do this? How do we go about doing this? In our, sorry. You could do this a couple of different ways. You could actually just write x1. You could define x1 right now, equaling these equations. So you just write x1 equals negative b, and it knows what b is because that's already been an equation. That's already been input. It assigns whatever the user puts in second as b, so it's there. And we can do that, b, negative b plus, and then we can do square root of b squared minus 4 times a times c, right? So and then this whole thing is going to have to be over 2 times a, so we go ahead and put parentheses around the whole thing, divided by 2, divided by a. If you divide it by 2a like this, you divide it by 2 times a like this, it'll divide by 2 and then multiply the whole thing times a. So if you do that, you need to put parentheses around it. You can do it that way too. And I want to suppress this output, so I'm going to go ahead and put a semicolon there, and then I can do the same thing for x2, which will be the same thing really. So I'll just copy it and paste it here, except there'll be a minus sign. Now you can do it that way, but there are other clever ways to do it. You could also take this part right here, this b squared minus 4ac, and cut that out and define that as something different. Let's say we define that as d equals that, and you could calculate that part separately and then put it in here. You could have, and you want to put the square root of that up on there, square root. And then you just have b plus d, and you put your parentheses in here, all over 2 times a. And then you'd have b minus d over 2 times a. You could do it that way. And just kind of break it up a little bit to make it a little simpler looking, apparently, so that these aren't so long. And that's perfectly fine. A lot of people will do that because this part of the equation, which is usually called the discriminator, I believe they call it, tells you whether or not you're going to have a real or an imaginary, real or a complex solution. And sometimes that's useful for people. But anyway, the function here will work either way that we've done it. And that's fine. And then at the end of it, we want to put end. You want to make sure that you suppress output. You don't want to print things to the screen all the time, because this function is going to spit out the answers already. It's already going to give the 2 answers out when we're done. And when we're done with this, we want to go ahead and save that. And it saves it over here in our current folder as quadform.m. Then I can go down here to my command window, hopefully, and use quadform as a function in MATLAB. And it's going to accept 3 arguments. The arguments I'm going to give it are 1, comma, 2, and 1. And let's see what it gives us. It gives us an answer of negative 1. Is that correct? I don't think so. Why does it give me an answer of negative 1? Let's see. Let's actually unsuppress our outputs here and see. Oh, here we go. I did x1 twice. I want to do x1 and x2. So let's do that. So the answer negative 1 essentially said that this wasn't working because I didn't have 2 answers in here. So when I didn't have my I didn't have x1 and x2 defined in here, it didn't know what to do because it was expecting 2 outputs. Now it has 2 outputs to go. So let's try it again. Let's try quad form 1, 2, 1. Hit enter. And it gives me an answer. X1 equals negative 1. I didn't do the other one, so let's try it again. Save. And let's do it again here. So this one is giving me an answer, x1 equals negative 1, x2 equals negative 1. I think that's actually incorrect, and I'm trying to figure out what I did wrong here. Negative b plus or minus the square root minus the square root of b squared minus 4. Square root of b squared minus 4. I must have done something wrong in my equation up here. I certainly did something wrong. 4 times A times C. Because this is supposed to be 1 and 1, I believe. Square root of B squared is 4 squared. Now, like I said, I'm going to be kind of winging my way through this today, and it's not necessarily working well for me. Let's save it again and see if we can run it one more time here. Quad form 1, 2, and 1. It's given it to me backwards, and I don't know why. Well, I've done something wrong with a negative sign here, and I'm not sure where it is. Let's see if it's where I put it in the parentheses here. That shouldn't be correct, I don't think, but let's try it anyway. No, it doesn't change anything. Well, that's okay. Let's do something else. Zero. Well, that gives me the right answer. And I don't know why, but it does. Oh, it's actually over negative 2a, isn't it? Is that right? I think it is. That's the reason. Let's try that. I think I put in the quadratic formula wrong. That's okay. Okay, so anyway, let's try this quadratic formula. Okay, so now that's working. If we did a different one, let's say 1, 6, 9, for example. 1, 6, 9, right? It gives us the answers we're looking for as well. And we could do, and what I'm solving for here is just different quadratic formulas or different quadratic equations with different coefficients that I know the answers of to check my work. And so it's working so far. If I did, for example, 8, 1, 6, 8, I should get an answer of 2 and 4. And so we plug that in and I get an answer of 2 and 4. If I plug in 1, negative 6, 8, I should get, no, if I put it in 1, 2, negative 8, there we go. If I put in 1, 2, negative 8, then I should get a positive 4 and a negative 2, hopefully. And that's what I get, a positive 4 and a negative 2. So it's working, and that's good. I just had the formula wrong up here. And that often happens when you're working with MATLAB, as we know, but particularly when you're working with functions, because you have a lot of things going on all at once in here. But notice that I don't have to rewrite this function every time. I just put in quad form and put in the values. Now another thing that I can do is I can go up here and suppress these outputs again, which is fine. It's just going to, when I do this quad form thing here, it's going to give me it's only going to give me the first answer out. But I can actually I can actually now assign the outputs by putting in some square brackets and giving some names. So let's call them R1, for example, comma R2. And what this little thing does is it tells MATLAB to put the answers from quad form. Oops. So if I put in quad form here, and I want to put in 1, comma 2, comma -8, for example, then it's going to assign x1 and x2 to these two variables. So I go ahead and press enter there, and it tells me that R1 is now equal to -2, R2 is equal to 4, and it stores those answers. Before, it was not storing the answers over here. When we just put in quad form 1, 2, -8, notice that it didn't store any values for x1 and x2 over here. Those values are only remembered while this function is running, and then after the function finishes running, it forgets them. But over here, it actually puts them in the workspace. Right? So that's an important. It's an important thing. These are what we call local variables that are they're remembered within the function. And these are essentially global variables that everything knows about. The entire MATLAB program knows about these variables over here. And because they're in our workspace, they've been saved out there. So that's important when you're building functions. Let's see what else we can learn about functions here. Probably what I want to do at this point is kind of go to the might want to just go to the homework. Let's take a look at one other thing in functions here. Okay, so well, let's just go. I'm going to look at the homework. I'm opening the homework on a separate thing here. I'm trying to, right? And you kind of want to just go through and learn the things that we need to learn to do the homework, because functions are a very huge topic. We're going to only look at a few parts, a few things concerning them. So in our week 6 assignment here, let's take a look at different things with functions. First of all, for today's class, instead of just submitting an M file that shows everything that we did in class, you're going to do that, but I'm going to be making several different M files. You don't need to make several different M files. Just kind of take notes in one M file and then turn them in. But anyway, we can, let's see, what's another thing we can do here? So we can create an M file that can accept arrays of numbers. So let me think of one here really quickly we can do. Let's create an M file. We'll call it distance, falling distance. No, let's call it falling speed. Okay, so I'm going to go ahead and actually, instead of just creating a new file here, I'm actually going to go up here and use this open new thing here. I'm going to do new function so it starts it off right for me. And my new function here I'm going to call fall speed. And with this one's going to calculate, this function calculates the final speed of a falling object before it hits the ground. And this one, in the detailed explanation, I'm going to tell what we're going to plug in. This function accepts inputs of, I'm going to say array inputs, so it can be one or many numbers, of initial height, and pretty much that's all we need. We could also do initial speed, I suppose, but for now we'll just do initial height. And so, assuming the initial speed is 0, we're going to assume that we're just dropping it, we're not throwing it down or throwing it up or anything else. And the equation for this is going to look something like this. We're going to have an h. So our output argument is going to be an h. We'll call it h for height. And the fall speed input is going to be, sorry, no, the output is going to be speed, right? We call the output fall speed. Well, you don't want to use the same name as your function as your output variable, so we'll just call it fs. Yes. Oops. So our output is going to be fall speed. Our input is going to be, well, we can go ahead and use h here. We'll use h. That's fine. Okay, no, we don't want to use h. Let's use fall speed. And then down here we want to use fall speed. And then over here we want to actually input the height that we're going to start at, so we'll use h for that. That's fine. Down here our equation is going to be fall speed is going to equal our beginning height. Let's see if I can remember this equation off the top of my head. It's going to be 1/2. It's going to be the height times I can't remember it all of a sudden. Let me write it down on a piece of paper so I remember what it is. I can't seem to remember what it is. Let's look it up. That's always a good idea. No, come on, where's my... There we go. So we're looking up for free fall speed from height h. And the free fall speed, which is right here, if we know the height, is actually square root of 2 times the acceleration g times the distance. I knew there was a square root in there, I just didn't know it was under it. Okay, so it's going to be 2 times, and the g is actually the gravitational constant, right? Which is 9.8 meters per second. And then times the height that we're going to plug in, or the distance that it falls, so it's h. And that whole thing has to be under the square root. So there's our fall speed. And we can go ahead and suppress that or not, just depends on what I want. Since we only have one output, we're good to go. And we can go ahead and run this and see how it goes. We'll save it. And it should save as fall speed, right? And then what we want to do is we want to check to see if this is going to work. Fall speed. And we want to put in not just one number, we want to put in a whole array of numbers, so a bunch of numbers. So let's go all the numbers between 1 and 100, for example, and see what this gives us. So hit enter. So it looks like everything works. It gives us 1 through 100 columns of numbers, right? But what if we wanted to enhance this a little bit? Let's say we don't want to just, we don't want to necessarily just have numbers listed off. Let's say that we want to make a graph of it, for example. This is going to get a little bit tricky because for a graph you need 2 sets of numbers, one for your y and one for your x, and they need to be the same length. However, every time they plug in the number h, we can figure out how long it is. So we can actually say, let's call L equal, let's let L equal the length of h, for example. We'll suppress that. So now we've stored the length of the vector that they put in. Whatever vector they enter in, we'll know the length of it. And then we can create another vector. We can call it our x vector, for example. Let x equal 1 to L in 1 step length. That will give us a vector that is the same length as whatever vector they give us. So it's going to give us that number of spots. We'll make this vector. Then we can go ahead and plot, because now we can plot L on our x-axis and Fs on our y-axis, and we'll see what happens. So we'll save this here, and we'll go here back to fall speed, and we put it in there, and it's going to hopefully plot it for us. Looks like it did not plot it for us for some reason. I think we did it backwards. Let's see. Into L. So let's try it again really quick and hopefully we'll see what's happening. So on this x-axis we have this range this domain that's going from 99 to 101. I'm not sure why it's doing that, so we have to figure out that mistake. And then this one is going from 0 to 45. So it's just not showing us anything, of course, which is not helping. Let's see if we can't figure out what's going on here. So L, if I just type in L, let's see if it recognizes it, so it doesn't. If I type in, put X out here. I'm going to bring all my variables out here so I can see what they are. Save, and I'm going to run this again. And so now I should have L printed here somewhere. So this is X. One to 100. Oh, that's right. That's what I did wrong. I should have plotted X, not L. So I changed X. I figured out how long H was, and then I created this vector, and then I put the wrong thing there. I put L versus FS. And that's why we got a blank thing, because there's nothing at that number for f of s. But let's go ahead and do it again. So we save this, and we can actually suppress these again because we don't need them again. And we'll save, and then we'll run this again. So if you didn't catch what I did wrong, I found the length of my vector h, and then I plugged that length into the plot. So what it did is it only plotted one point. It was looking for f of s at x equals 100, but there was nothing at x equals 100 for f of s. So that was a blank plot. But I was supposed to put in x so I can see all of the different things that are happening for f of s. So we'll go ahead and do that, and we'll save that. Then we'll go ahead and run this again and see what happens for us. Hopefully something good. And our plot's not here because it's hiding. Let's find our plot. There's our plot. And that's what we see. Now we're seeing that we have this, so it looks like we're actually plotting something slightly differently than we wanted to. We have heights going from 1 to 100, I guess, and no, I guess this is right. Doesn't really look right, but that's okay. We'll figure it out here in a second. But anyway, at 1, so this is at 1, we have a speed of, looks like when it's falling, you get a speed of maybe 4 point something, 4.9 maybe, which is what we would expect actually from 1 meter falling. And as you get to 2, it goes higher and it goes higher and it goes higher and it goes higher and it goes higher. You get faster and faster speeds the higher you go. At 100, you get a final speed of 40 something meters per second. And that is what we would expect because we do get a square root, so that is right. I was thinking backwards. But so this final speed should look like a square root graph, which it does. The square root graph does kind of tip over like this. And we've got a nice plot, and all we had to do is create a function. But this function calculates the final speed, and it can calculate it in an array. It can calculate the length of the vector that was plugged in, which was the h. It can also use that length to make a new vector within the function. And then it can use that vector, the new vector we created, and the vector that was inputted to make a plot. Right? Now, you might have said, why don't we just use h here? Because we could have done that. We could have just used that in the plot. If I go to plot and I just plug in h, comma f of s, that's perfectly fine. It will work. And in fact, it's a little more elegant because it's less code. It gives you the same exact result. But sometimes there is a reason to take one vector, find out how long it is, and make a new vector. That's often the case. So for example, if we're entering things in meters and we want to change things to feet, we might want to use the length of that vector to create a new vector that gives us in feet. And how would we do that? Well, we would find out the length of h, essentially, or we could just multiply h. But anyway, what we would do is we would take each one of these meters in here, and we would multiply it. We would go in steps of 3.2, essentially, which is how many feet are in a meter, 3.2. So we would start at 3.2 feet. We would take steps of 3.2. So take steps of 3.2. And we would go all the way up to 100 times 3.2, so this length times 3.2. And that would give us a new plot of all this, of the speed as it goes for a number of feet. So if I save that way. So essentially you can create new vectors of the same length of the vectors that were plugged in, which is very important because when you're doing mathematics in MATLAB, your vectors have to match when you're doing mathematics. So that's kind of how that goes. So here's my fall speed now. Hit this enter, and you can, well, it didn't quite change it for me because I didn't put the right name in there. Let's fix that. Got to put X in here again. Save. Okay, so now the scale, instead of going from 0 to 100 meters, it goes from 0 to 320 feet. So you can see how fast, and this is still in meters over here, and we could make that conversion inside of the function as well. So that the speed is in feet per second or in miles per hour or whatever we want. And we can do that all within the function and have it done all at once just by plugging in numbers. And that is a very simple function. Or second very simple function. Let's see, what else can we learn about functions? Okay, the next thing we're going to learn about functions is creating an anonymous function. If we go back to our idea where we were using functions, first we were typing things into M files, just like this, where we just type in commands into M files and run them, and they just go command by command, whatever, and that happens the way it happens. To using M files as functions, where we type an input into the function, and then it runs some code and changes it, and it spits out some output. But you can also actually create functions right inside of the command window. And these are what we call anonymous functions. And let's actually type in help anonymous. Is that how you spell that? We'll type in help anonymous. Did I say it right? Functions. I must have spelled it wrong. Anonymous. That's right. Okay. So let's do it right here. Anonymous functions. So what are anonymous functions? So an anonymous function is essentially one that you can type directly into the command window. And here they say that it's not stored in a program file. So we're not going to open an M file, and it's not going to be stored in our system somewhere. Essentially where it's going to be stored is it's going to be stored in MATLAB. MATLAB is a place for storing anonymous functions. And as long as you've got the command window running and you don't clear out the command window, it will remember this particular function that you made. So for example, we can create the anonymous function, this anonymous function that creates the square of a number. It's pretty easy. I'm just going to copy this code into my thing here. I'm going to put it right in my command window. And what this means is that I'm creating a function that's called square, SQR, and it's going to be this at symbol tells you that this number points to this code. So square is at X, and the X is the thing we plug in, so that's the number we plug in, and whatever we plug in goes into this thing right here, X dot squared. They put the dot there so that you can square vectors and arrays just like you would square numbers. Then I just press enter, and now MATLAB stores this thing over here in its workspace, but it's not necessarily stored in our folder. It's just stored in this workspace. So MATLAB's got a little function for this. If you open this up, it opens it up as a function handle, they call it. So the function handle is SQR. That's the handle. And if I want to use it, I put SQR, and then I put some parentheses, and I put in whatever I want to square, and I hit return, and it squares it. And these can be you can do several lines of code with these if you want. So they can do fairly complex things. You can, like I said, with this one, you can square an array. For example, if I want to square the array 3, 4, 5, I can go ahead and do that, and it squares it 9, 16, 25. You're good to go. It'll square negative numbers and complex numbers and whatever else you want. But this is an anonymous function because if I come down here and I do clear command window, CLC, well, actually not clear command window, if I do clear all, then it clears my workspace, and I can't use it again. If I go back here and put square in here of 9, it has no idea how to do it because I've cleared that out of my workspace. So that is what we do, what we call anonymous functions with function handles. Pretty simple to do, but not as easy to work with because you can't edit them when something goes wrong so easily. You can't go back. I mean, I can go back and go back to this code here, but if I had multiple lines of code, I couldn't select all those multiple lines of code. So I could go back to here and I could change this if I needed to, but if I had multiple lines, it wouldn't necessarily let me do it. So it's much easier for more advanced things to go ahead and write an M file, open a function M file, and build your code. Of course, it's a good idea to annotate your code, which I, again, don't do all that often in class because I'm talking and trying to figure things out on the fly. But you might want to say, this is the first solution. You might want to say on this part, this is the discriminant, they call it. Whatever. So just when people open up this M file that has this function in it, they know how to use it, and they can figure out what to do without too much trouble. All right, moving right along. I think that we're pretty close to being done here, covering the stuff that we need to cover. We might do one more example of an M file. Oh, we also have subfunctions. Let's do that one real quick. So let's go back down here. Let's do help subfunctions. Of course, it doesn't bring it up, but if I search the documentation, it brings up, let's see, local functions, programming scripts and functions. Yeah, subfunctions here. So essentially, you can actually have multiple functions within a function. And here's an example of this. We have, this is a statistics function, essentially. It's designed to take some statistics of numbers, some averages and medians and means and other things like this. And so what they've done is they've done 3 different things. And in this first one, they're just taking the average of a group of numbers and then taking the median of a group of numbers. They first find the length, and then they plug them into my mean, my median, and they're good to go. However, my mean and my median are actually functions. Notice that they're not using, they're using a slightly different syntax here than they used up here. Up here they have the things that you put in, the things that you're going to get out are average and median. The thing that you put in was this array of numbers x, and then they start using x. They first find the length of x, and then they're using they're saying that the average is going to equal my mean of x comma n. But then these things here this is a whole new calling of a function essentially. So my mean is going to have 2 inputs, x and n, and so we have to define that function. That function is going to use is going to have a value that it's going to put out. This is the output again, but notice it doesn't use the brackets, so we're using slightly different syntax here for the subfunction. The main function has the output in brackets, that's what goes outside the function. The subfunction has an output that is used within here. So we're going to have A is going to equal my mean of V and N. Well, what's V? V is going to be the sum. We're going to take a sum of V over N, but where did V come from? We got to get V still. So there's another subfunction. Subfunction here, my median. I actually don't see where they use V at all. Where do they define V? That's confusing me. Oh, so sorry, I was a little confused what they did here. But what they did here is they're taking this function, they're calling out this function that they haven't made yet, my mean uses x, and then when they call it again, my mean here, and they replace x with v, that actually makes x, that it replaces the thing that was put in, x, with v. And this is actually, you could actually leave it as x if you wanted to, but it's actually good programming to change that variable, to change the name of that array, because you don't necessarily want to change the array that is put in. And down here, they're going to make some changes to it. They're going to divide things, they're going to add things. So they want to leave x alone, so they're just going to make a new array called v that has the same things as x in it, and then they're going to use that down here. They're going to take the sum of all those numbers, so they're going to add up all the numbers that are in the array, they're going to divide by n, and they're going to give that the name a, and then that a is going to be used down here. Well, they're going to use v again. They're going to change x into v again down here. They're actually not going to use a anywhere. They're going to just put it back out to the output again. So that's going to be an output up to here, and that'll end up in our average. And then down here, the subfunction is going to have this m output, and the m is going to be the output of my median, and my median, the output is called median, is called med. So this function sends something to AVG, which is going to be sent out of the function. This one sends m to med, which is going to be sent out of the function. And it gets really confusing because they keep renaming things. But there is a reason for that. The reason that they rename them is to preserve the original things that were sent in, and to make sure that the things that are sent out are, it's kind of like money laundering. Criminals launder money by running it through some business, and you may run $50,000 through a business and get $50,000 out, but the $50,000 out is different money, it's untraceable. And that original money that was so dirty and dangerous is not in your hands or whatever. That's how criminals do money laundering. Well, this is kind of like variable laundering. We have variables that come in that we don't want to mess up, we don't want to mess with, we don't want to touch them. We want to leave them alone as they are. And so we just create a new variable that has a new name that is the same thing, or a new array that is the same thing. And then we use that array, and we do that twice in here. We do it from here to here, and from here to here, and then back. And so we do it as we're going in, we rename x v, so we're using x as v, it's coming in, and then going out, we're renaming average a, and then a goes back into average. But it's kind of probably the easiest way to kind of sort these things out is to have an example of it. And so that's why we make these examples, and we go through and we follow the example to make our own. So if I copy this and put it in my function, or put it in my my new function, which I'm going to open. Let's open a new function. Here, just punch it in here. Then we should be able to create an average of any group of numbers, and that's fine. That's great. We'll do that. Let's go ahead and save. Let's go ahead and save this properly. We're going to have two output arguments. My two output arguments, and actually what we've done here is we've put a function inside of a function inside of a function. Since they already had this function in here, I can erase all this stuff out of there because they've already put the function in. So there's our outputs, average and median are our outputs. Our inputs are just x, so you can have more outputs than inputs, and then we can get rid of one of these n's because we don't need it. We have too many n's. And you should always check how many n's you have. You should have an n to every function, and you should have an n at the end of the entire file. So here's our main function, it has an n. Here's our subfunction 1. Here's our second subfunction 2, and then there's an n at the end of the whole thing. So we're good to go. Functions within functions. We go ahead and save that, and it saves it as my stats. And then we can come down here and we can say my stats. And I'm going to put an array. I'll put an array of numbers from I'll just put in a random array of numbers. Let's see if I can actually do this here. random array of 44 numbers. So it gives me 44 numbers to start, and that's my thing there. And then what this has done is actually this gives me a random square array of 44 numbers. And then what it did is it took the average of every column. So it took the average and median of every column in the end. And if I want to do this same thing here, and let's assign the first answer out, which is the mean. We'll call that mean, and the second one the median, right? Then I get two arrays out. I get one for the mean and one for the median. Well, the median ends up just being one number. So that is the idea of subfunctions within functions. Functions within functions within functions. And I highly recommend that you use the help tool a lot and just copy things in and try to modify them when you're making functions. Particularly this new function tool is very helpful, where you can just open up a function that's already got the function, the starting script here at the top and the end at the bottom, so you're just filling in stuff in between. That's very helpful as well. But that is the end of this material. I don't think I have anything else to share with you. We've given quite a few examples. Let's see, I'm looking at the homework to make sure there's nothing else I need to. I think I've given enough information to you to go ahead and get started. Make sure that you remember in the homework there are several examples where you're going to be multiplying arrays of numbers together, and you have to make sure that you know how those are going to multiply together. Use the dot times thing, right? So if let's say that I'm multiplying voltage and current together to get power. Power equals voltage times current. If I define an array voltage to be equal to this array 1, 2, 3, 4, or something like this, so there's my voltage. And then I define an array current to equal 4, 3, 2, 1, right? And then I try to multiply voltage times current, because voltage times current is my power. It doesn't like it. It says the inner matrix dimensions must agree. And that is true if you're doing linear algebra, but since we're just multiplying numbers together, we need to put voltage dot current, which means that I'm going to multiply the first one here times the first one here, and the second one here times the second one here. And that's the kind of math that we're doing in this class, and so we get the correct answer out. And in some situations, I might ask you to do something like, tell me the power for these different voltages, for voltage, that array, but all at the same current, all at 10 amps or something. So then you would take the voltage array, and you would multiply, you could multiply the whole thing by 10, and it would give you 10, 20, 30, 40, and so on and so forth. And that way, you can, if you're multiplying everything by the same number, you can just multiply by 10. But the other one, you have to use the dot times. So when in doubt, use the dot times, because voltage times dot times 10 will give me the same answer. It doesn't change anything. It works just fine that way. So use the dot times, the dot divide, the dot squared thing is a good idea, just so that you're doing the math the way that we do it in this class. Are there any questions about what you're going to be doing here as we move forward? If there are no questions, then we can go ahead and end for today. That was pretty quick for today. We usually go about an hour longer than that. But If you do have questions later, please feel free to email me. You're welcome to send me a file of things that's not working, a file of a function that's not working, and I can help you make it work, point out some things that maybe need to be changed. I've given you looks like 9 different problems to do, and it's all 9 different questions on the test, because you're going to have to submit a different M file or a different function file for each one of those problems. So don't be alarmed that there's 8 different things to upload. Each one of those is just a different function file. And I'll leave you to it. Have a good week, and I'll be looking for my emails from you if you need any help. Have a good one. Bye. What's that? Are you speaking to me? Oh, okay. You're good to go? All right. Stop the video.